Hi, Mrs. McTaggart here, and what we've got is a practice paper that I would use a higher supported study over Easter. It's one that you won't find on the websites as normal. It's from a past paper book that isn't really that well circulated, and I've pulled out a lot of questions from it, and obviously I've removed things that we won't be testing in for our school. So questions that will be missing are circle, logs, exponentials, wave function, and the movement of graphs. So they are all missing from this. There is a predominantly more heavy focus on later topics, such as composite and inverse functions, integration, further calculus, and all your double angle formula. So let's just start. So the first wee bit is all paper 1. And of course, we do have a lot of multiple choice questions, and I know multiple choice isn't in it anymore, but they're still really useful for just testing your core skills, okay? Okay, so this one tells us what f of x is, and it talks about a suitable domain for f is a set of real numbers apart from which value. So you just have to watch the wording for this one. It could always ask for a suitable domain, or it could ask for restrictions on a domain, which is what this is really asking for. So we need to find what numbers do we put in this that make it not work. Now, when you've got a fraction, you cannot have this bottom line equals 0. So let's find out what numbers do make it equal 0. So we'll start by writing out that trinomial and putting it equal to 0. Now we don't need the 2 because that's just a multiple. So we've got x squared minus 3x plus 2 all equals 0. If we factorise that, you are looking for numbers that multiply to 2. So it's got to be 2 and 1, and it'll be minus 2 minus 1 to make that work. So x equals 2, if you put that equal to 0, and x equals 1. Now, these are the numbers that we put in that make it not work. So that means that our restrictions on the domain are C. Okay, so in this question, we're given an expression for dy by dx, and we're told that a curve passes through the origin and we have to find its equation. So if you've been given dy by dx and they're asking for an equation, which is y equals, they're asking you to integrate. So we are technically being asked to integrate 4x cubed minus x squared minus 1. Now when you integrate, you increase the power and you divide by the new power. So this gives us 4x4 over 4, take away x cubed over 3, take away 1x, and don't forget your plus c. Now because they've told you that it passes through the origin, that means that there is no value for c at all. It's just going to be y equals this. Now when you simplify that, the 4 over 4 cancel, so you're just with x4, take away x cubed over 3, take away x. And that marries up with question A. The only difference is they've written a third out the front. I've left it as x cubed over 3, which is perfectly okay. So it's recognising that you have to integrate. Now, if they didn't tell you the origin was 0, 0, what you would do is you would take your coordinate, you would label it x, y, and you would replace x and y with what those numbers were, and then that would work out what c is. There is just no c value in this one because it passes through the origin, so it makes it a bit easier. Okay, question 3, we're asked, what is the value of sine 2y? So the minute I see sine 2y, I want to rewrite that as 2 sine y cos y. That is the expansion from your formula sheet for sine 2y. Now, sine y and cos y we're going to get by using SOHCAHTOA. So if this is angle y, this is your opposite, your adjacent, your hypotenuse. So we have 2 times sine y is opposite over hypotenuse, so that's 2 over 2 root 3 times cos y is adjacent over hypotenuse, which is 2 root 2 over 2 root 3. Now you can do some cancelling if you want to here. I'm just going to show you that these are going to disappear. So that 2 and that 2 cancel, that 2 and that 2 cancel. And on the top, you're left with a 2 times a root 2. So you've got 2 root 2 on the top. And in the bottom, you've got root 3 times root 3, which is just 3. And then that matches up with answer C. Question 4, we are asked to find f of g of x. So f of g of x means anywhere in f, we are replacing it with the function that g of x is. So we're replacing it with that. So into the equation for f, we've got root x, so that becomes the square root of 3 take away x, and that would be part B for that one. Question 5, of a sequence. So this says un squared. Now, I would actually probably prefer that if there was a wee bracket there. So un squared take away 1, and we're told what u0 is, and we have to find u2. So u1 would be plugging in u0, so we've got minus 2 squared take away 1. Now, minus 2 squared is just 4, take away 1 is 3. And then u2 would be plugging that in. So that would be doing 3 squared take away 1, which is 9 take away 1, which is 8. So answer C. Question 6 is asking us to integrate, so we have to do a preparation line first. That is the same as asking you to integrate 3x to the negative 1/2. Square root is a power of half, and we're bringing it up to the top, so it's got a negative power. Now, when you integrate, you increase the power. So minus 1/2 goes up to positive 1/2. You divide by the new power, and don't forget to add on c. Now, to simplify that, dividing by the half is the same as timesing by 2. So that 2 effectively comes up to the top line. So you've got 6x to the power of half. There's just 1 left in the bottom, so we don't write anything. And that gives you that. Now, remembering that power of half is the same as a square root, that would be that one there, which matches up with question A. Okay, they want the distance between two coordinates, so this is like magnitude. So that's using the really long kind of distance formula, or the find the distance between each of your coordinates, between your x's, your y's and your z's. So you're going to subtract your x's, so we've got minus 1 minus 0 all squared. Then add on, subtract your y's, so minus 3 minus 5 all squared. And then add on your 5 minus 2 all squared. Alternatively, you could just compare the numbers and say, right, from minus 1 to 0 is 1, so that's 1 squared. From minus 3 to 5 is 8, so you could then just put in plus 8 squared there. But technically it's minus 8 squared. It gives you the same answer because 8 squared and minus 8 squared are the same. And then from 5 to minus 2 is 7, so it's plus 7 squared. So we have the square root of 1 plus 64 plus 49. So that's the same as 64 plus 50, that's 114. So it's the square root of 114, which is D. Question 8 wants you to find the exact value of cos p plus q, so that is your expansion. So cos p plus q is the same as cos p cos q. Subtract sine p sine q. So that's what we have to work out. Now there's some missing numbers on our triangles here. This little one here that I've just drawn over, that would be 1 squared plus 2 squared, which is 5. So this would be the square root of 5. And then the combined length along the bottom, if I'm using q, would be 3. So I'm actually just going to draw that triangle out again separate. So here is angle q. This is root 13. This is 3. And this is 2. So I've got opposite, adjacent, hypotenuse, opposite, adjacent, hypotenuse. So there's my two triangles. So cos p is 1 over root 5. Cos q is 3 over root 13. Take away. Sine p is 2 over root 5. And sine q is 2 over root 13. So multiply the top numbers and the bottom numbers, so you end up with 3 over, now root 5, root 13 can multiply together and give you the square root of 65. Take away 2 2s are 4, so 4 over root 65. And then that gives you negative 1 over square root of 65, which matches up with B. Question 9, we're told that it has equal roots. Equal roots means you can set b squared minus 4ac equal to 0. A is 3, b is 1, c is m. So we have 1 squared, take away 4 times 3 times m equals 0. So you've got 1 take away 12m is 0. 1 equals 12m. 1 over 12 equals m. So it is C. Question 10 is completing the square. I'm just going to rewrite this in this order. So all I've done is I've just put it with the x squared at the front. I'm going to take out a common factor of -1 from the first two terms. Now, some teachers do this a wee bit differently. I just take the common factor out the first two. Some people take it out of absolutely everything. So this leaves us with x squared plus 8x and then a plus 7 on the outside. Now I complete the square of the bit in the square brackets. So that's x plus a half of 8 is 4. And then I take away 4 squared, so I take away 16. And then I've got a plus 7 on the outside. Then I reintroduce the negative. So I've got a negative in front of my bracket. That becomes plus 16 plus 7. 16 plus 7 is 23. And if I write it in their form, it's 23. Take away your bracket squared. Now they said, what is the value of A? A is 23. So it's D, positive 23. Question 11, we're told that these points are collinear. What is the value of T? So if they are collinear, then A to B and B to C should be multiples of each other. So that's what we are going to find out. So A to B is B take away A, which is 6, 1, 1. Take away 10 minus 1, 3. And that will give us 6 take away 10 is minus 4. That becomes 1 plus 1, which is 2. 1 take away 3 is minus 2. And then if I do B to C, that's C minus B. So that gives me 4, 2, T. Take away 6, 1, 1. Which gives me minus 2, 1, and T take away 1. Okay, so you'll notice that basically BC is half of AB, right? So BC is half of AB. Do you agree? It is. All those numbers are just half. So what that means is you can then write your bottom line, the one with the unknown, the one with the T in it. You can write that T minus 1 equals a half of minus 2. So T minus 1, because that's the ones that correspond in the same row. So T minus 1 equals minus 1. If you take minus 1 over, it becomes plus, and that just becomes 0. So the value of T is 0, which means we're going with A for this one. Okay, we've been given an expression for y. We need to find dy by dx. First of all, we need to simplify that. So y equals, we're going to break each thing up and write it as each term over x, which gives you x cubed plus x to the negative 1. We're going to differentiate, so we times by the power and lower the power. So 3x squared, and then that becomes negative 1. I don't need the 1 actually. So that becomes negative x to the negative 2. And if you rewrite that, it's 3x squared take away 1 over x squared, which matches up with D. Okay, so we're being asked to integrate this. So my trick for integration is I write sine cos minus cos at the side. When you integrate cos, it becomes sine. So this becomes sine a half x. And then you have to divide by what you get when you differentiate that. So we're dividing by a half. Now remember, dividing by 1/2 is the same as times by 2 over 1. So it's the same as times by 2. So this becomes 2 sine 1/2 x. And then we're plugging in pi over 3 and 0. Now pi over 3 is just 60, so you might want to think of it as 60 instead. So you've got 2 sine, half of 60 is 30. Take away 2 sine, half of 0 is still 0. Now sine of 30 comes from your equilateral triangle, where they split the 60 down the middle, making it 30. The side was 2, 1 and root 3. So your opposite would be 1 over 2. So sine 30 is a half. So you've got 2 times a half. Sine of 0 comes from your sine graph. Sine of 0 is just 0. So you've got 2 times a half, which is just 1 for your final answer, which is C. Question 14 says which is the correct one for this equation. So let's say, first of all, the amplitude is half and minus a half. So it's definitely not B and it's definitely not C. So we've got 1/2. It is a cos graph. Now, the period of the graph is 2 pi over 3, and that means 2 pi over 3 is 2 lots of 60, so that's 120. So if this graph repeats every 120, how many of them could you fit in between 0 and 360? You could fit in 3 of them, so it's a cos 3x. It's not been moved up anything because it goes from 1/2 to minus 1/2, so we are done. So that leaves us with D there. So it's a half cos 3x. Technically, that could be a wee National 5 one if they just took out the radians. Question 15, right, so we're on to the actual big questions. It asks us to find the stationary points on the curve and justify their nature, and therefore sketch it. So this is what I call a bread and butter question. If this comes up, brilliant. We know the method for stationary point, differentiate, nature table, and so on. So the first thing we're going to do is find the stationary points on the curve. So I'm going to write out the equation of the curve again. So I have y equals x cubed minus 3x squared plus 4. We're going to differentiate, dy by dx equals, times with the power and lower the power, so that becomes 3x squared. Take away 6x to the power 1, 4 disappears, so we've got that. And remember, for stationary points, we always put our f dashed x, or in this case dy by dx, equal to 0. So we put that equal to 0. There's a common factor of 3x here, leaving you with x take away 2. Split them up, we get x is 0, and we get x equals 2. Now, if we plug them back into the original equation, when you plug in the numbers, the number x is 0, you end up with just 4. Because you cut 0 cubed, 0 squared is just 0, so you end up with that. So we know our first coordinate is 0, 4. When you plug in the number 2, I'm just going to do the working up here in the top right. 2 cubed is 8, 2 squared is 4, times 3 is 12, so take away 12 plus 4. That just gives us 0, so y equals 0 in that case, so the other coordinate is 2, 0. So I've got the coordinates, I just have to decide their nature now. So I'm going to do a wee nature table. So we do everything up to, sorry, not 0, we do everything up to 2, and then everything, no, we do it as 0, sorry. We do everything up to 0, and then everything up to 2, and then everything beyond. We write our dy by dx and our shape. Okay, you pick numbers less than 0 and plug it into dy by dx. Remember, this is our dy by dx over here, so that's where I'm substituting into. So any number less than 0, just go with -1 if you want. -1 squared is 1. 3 times 1 is 3. So we've got -3 minus 6 times -1 gives you +6. So that's positive. Plugging in the number 1, you just end up with 3 take away 6, which is negative. Number bigger than 2, let's go with 3. 3 squared is 9. 3 nines are 27. 27 take away 18. That's positive as well. So we have this shape. So 0, 4 is a maximum turning point, and 2, 0 is a minimum turning point. So that's us done part A for 7 marks. The next bit is a show that. So I'm just going to take a fresh page for this. Okay, so part B asks us to show that this thing multiplied out gives us that. So let's multiply it out. So first thing I'm going to do is I'm going to do the squared bracket. So I'm going to leave the x plus 1 at the front. X minus 2 all squared gives me x squared minus 4x plus 4. Now you can do that using a bit more working if you need to, but you should be able to square brackets quite higher. Then we multiply that out, giving us x cubed minus 4x squared plus 4x. Then we get plus 1x squared minus 4x plus 4. And when you tidy that up, you get x cubed minus 3x squared. The 4x's cancel out, and then you've just got your plus 4. So that was the show that they wanted. So that's part 1 done. Then says hence sketch the graph. So technically what they've done there is this bit here that I'm just putting a wee box around, they've already factorised it. And when you want to sketch a graph, you want to show where all the roots and things are, where it cuts the x-axis. Now they've already given you this by having it in factorised form. So I know that the roots here are x plus 1 equal to 0 means there's a root at x equals minus 1. And then x minus 2 repeated means that it is touching at x equals 2. And we already did that because you'll notice down here I've put down my bits from part A. There was my minimum turning point, so that's one where it's just touching, that's the repeated one. Sitting at 2, 0, and that was a minimum, and then we've got 0, 4 as a maximum. So we've got all the numbers we need to draw it. So all we need to do now is get our axes on it. So I'm going to put on my x and y axis. That'll do. Remember, this doesn't need to be drawn to scale, it just has to be like relatively in suitable places. So there is my axes. I know I have a minimum at 2, 0, which is just touching, so we're going to make that your 2, 0 sitting on the line. I know I have a maximum at 0, 4, so there's my maximum at 0, 4, and then it cuts at minus 1. So there is my shape. Oh, it's a wee bit wobbly, but I can do better, I promise. So the maximum there is at 4, so I've labelled the 4 up there, and it cuts at minus 1. That's everything you need in your diagram. Okay, that's a lovely question for 11 marks. Next one, we've got two cubic functions, f of x and g of x, and we're told what both are. We have to determine the x-coordinate of the points P, Q and R, the points of intersection. Anytime you have points of intersection, you set y equal to y. So you put your two functions equal to each other. So we're going to have 2x cubed plus 3x plus 12 equals all that other one. Then we're going to bring everything to one side. So the negative x cubed becomes positive, giving us 3x cubed. There's no x term to bring over, but there is an x squared term. Positive x squared will become negative x squared. Then you've got a plus 3x, and in terms of numbers, you'll have 12 take away 2 is 10. So we have that. Now to find the points of intersection from there, you can't factorise that easily, so we're going to have to do synthetic division using polynomials. So that's when we do like the little table. And we're going to put in a 3, a minus 16, a 3 and a 10. Okay. Now, I know a trick here. If all these numbers add up to 0, then I can use the number 1 in front of the table, and they do, because we've got 10 plus 3 plus 3 is 16. 16 take away 16 is 0, so I know I can put a number 1 here, and this will work. Good wee trick if you didn't know that. So we bring down the number 3. 3 times 1 is 3. 3 take away 16 is minus 13. Multiply it by 1, it doesn't change. 3 take away 13 is minus 10. It doesn't change. They add together and we get 0. So that was a really nice one to start off with. Now, that means when we factorise it, we have x take away 1, and then your quotient is 3x squared minus 13x minus 10. Okay, and we need to fully factorise this. Now, remember this was all equal in 0. So let's factorise the trinomial. So it's going to be a 3x and an x. Now you'll all have different ways of doing trinomials. Numbers that multiply to 10 are 2 and 5. If I put the 5 there, that'll give me minus 15. And I put a 2 there, that'll give me plus 2. That works. So from there, I know that x equals 1, x equals negative 2 over 3, and x equals 5. Now, the question asked just for the x coordinates. So it went PQR from left to right. So the x coordinate of P would be this one. So this is P, this is Q, and this is R. They only wanted the x coordinates, so that's it. That's enough done. Another nice question. Okay, so we've got another composite function question here. I just liked it because it talked about range in this one as well. So we're told f of x and g of x, and we have to find out what g of f of x is. So that means we are doing g of 3x minus 1. So into the g equation, wherever we see x, we now put in this bracket. So they have got x squared plus 7. So we replace x with our bracket, square it, plus 7. Now, I would leave it there like that, because the next part asks us to write down the coordinates of the minimum turning point. So it's already kind of incomplete in the square form. So for part B, the turning point would be, now you've got 3x minus 1, so you have to put that equal to 0. That would give you x equals 1/3. So you've got 1/3, and then plus 7 means it's gone up 7. So there is your turning point there. Okay, now they've already told us this is a minimum turning point, but we can tell that just from looking at the equation anyway. So we know we've got a minimum turning point. Now it asks for the range. Now range are like your answers that come out, domain of your input numbers, range of the values that come out. So the range of values, if you imagine this sketched, right, you have got a minimum turning point at 1/3 7. So no matter what value of x you put in here, you're always going to come out with a number greater than or equal to 7. So your range of answers will always be that y. It's your output numbers, so y is greater than or equal to 7, because that graph is never below the number 7 on the picture. So that's that one there. Okay, for question 18, we have an equation, and we have to solve this equation. Cos theta bracket cos theta minus 1 equals sine squared theta. Right, so sine squared theta sticks out for me. I don't want that there. So you need to remember that sine squared plus cos squared, I know I've dropped my x's there, equal 1. So sine squared x is 1 minus cos squared x. So that is what I'm going to replace the sine theta with. So what I've got is, I've got cos, if I multiply this out, I've got cos squared theta, take away cos theta, equals 1 minus cos squared theta. I'm going to bring everything to one side, so that minus becomes a positive. So I end up with 2 cos squared theta minus cos theta minus 1 equals 0. So I've now got a trinomial, one with a 2 cos theta in it, and one with just a cos theta. I'm looking for numbers that multiply to 1. It's got to be 1 and 1. You should be confident factorising by now. To get -1, that's going to be there from -2 and a plus there. So that is it. Always double check multiplying them out gives you back to what you started with. Please, please, please. Right, then we break both of them up. So the first equation gives us cos theta equals -1/2. The second equation gives us cos theta equals 1. Now you should know from your exact values now from these that cos of what gives you a half, it is 60. So our acute angle here is 60. We've got two different wee trig equations now to solve. So our acute angle is 60, and I'm saying acute angle because this is negative. Remember, when an equation is a cos is negative, we're going to use the sine and the tan boxes. So applying the 60 to both of those boxes, theta will be 180 take away 60, and 180 add 60, which gives you 120 and 240. Now, if I just look up at the top, it says it wants answers between pi and 2 pi. So I don't actually want that first answer because that's less than pi. So I'm using the 240. Now, 240 is the equivalent of 4 lots of 60. So that's 4 pi over 3. And another one, cos of theta is equal to 1. So cos theta is equal to 1 at 0 and 360. So that is 2 pi. So another one, we've got theta equals 0 and 360, which is 0 and 2 pi. But again, it wanted the answers between 180 and 360, so we can't really include either of those because it didn't have the less than or equal to sign. So both of these are all out with the range. So the only final answer we've got here is theta equals 4 pi over 3. Right, another trig equation I thought I would just put in was this one. So sine 2x is the thing that's going to replace in this one. Sine 2x is the same as 2 sine x cos x. And that is on your formula sheet as well. So this is what we are solving here. Remember from there it's factorising, and this one's got a common factor of sine x. So I'm going to do sine x bracket. That leaves me with 2 cos x minus root 3 equals 0. Then we split both of them up. So you have sine x equals 0 for your first equation, and you have cos x equals root 3 over 2 for your second equation. Now for your sine graph, it is equal 0 at these 3 places. So x equals 0, 180, but my question wants it in radians, so I'm going to write 180 as pi, and 360 is 2 pi. So there's my first couple of answers. For the second one, with a cos graph, when is cos equal to root 3 over 2? That's using your exact values. Root 3 over 2 is cos of 30. So your acute angle is 30, but because we're talking in radians, in fact, I'm just going to do it in degrees first of all, so it would be 30, but remember there's another answer. 360 take away that would be 330. So into radians, 30 degrees is pi over 6. That's 11 lots of that, so that would be 11 pi over 6. And then I just like to put them all in order at the end. You don't really need to, but that gives us 0, pi over 6, pi, 11 pi over 6, and 2 pi. Always double check your answer at the top that they want you to go all the way from 0 to 2 pi or 0 to 360, because sometimes they don't, sometimes they only want selected answers. Okay, so that is the answers to that one. Okay, another wee question. So another double angle formula question, I think, by the looks of it. So we're told this is a rectangle with point P lying on the side of AB 1 unit from A, and it tells us that A to D is 2 units. The dotted line in the diagram shows the bisector of the angle APC. So bisect means it cuts it right in half. So those two angles are the exact same. And it tells us that angle APD is the same as angle DPC. So they've marked it on, they've showed us the two y's. We have to find theta in terms of y. Now, theta over here. Right, we have to think back to like first year maths. How would we get this angle? First of all, we know this is a rectangle, so we know we've got right angles there. So to get theta, we need to think, right, what would you call this wee bit in here? The wee bit where I'm putting a dot. So the wee bit there where I'm putting the dot is 180 take away 2y. That's how I would get that wee angle there where I've put the dot, okay? We would then say, right, well, that angle of 180 take away 2y plus 90 plus theta all equals 180. Now, if we play around with this, the 180s will disappear, right? So theta will be, if you move everything to the right-hand side, it would be 2y take away 90. Okay, so that is what y would be. It would be 2y take away 90. Then it says find the exact value of sine theta. All right, so sine theta is sine of this thing here. So they're asking us to solve sine of 2y minus 90. That is what they're after. So we need to do our little expansions. So from our formula sheet, if we expand that, that gives us sine of 2y cos of 90 take away cos of 2y sine of 90. All right. Now, cos of 90 is 0. So I'm just going to do a wee bit of cancelling out. So that's just 0. And sine of 90 is 1. So if we then simplify that, the whole first term is 0. And then the second term is just negative cos 2y. So that's what we have to do. Now, if I go back to this first triangle, the one that goes APB, I'm just going to draw over it so you see which one I'm on about. If I use this one, cos of y is adjacent over hypotenuse. That hypotenuse there is root 3 because it's 1 squared plus 2 squared, which is 5. Sorry, it's root 5, not root 3. So cos 2y, I'm going to then think, right, what expansion of cos 2y do I want to use? You have a choice of 3 from your formula sheet. I'm going to use the one that's already got cos in it, which is the 2 cos squared y minus 1. So this will be 2 cos squared y minus 1. Okay, now cos of y is adjacent of hypotenuse, so that's 2 over root 5. Okay, so I have negative 2 times 2 over root 5 squared, and then that minus times minus will become plus 1. So I have negative 2 times 4 over 5 plus 1, which is negative 8 over 5 plus 1. And negative 8 over 5, well, that's like negative 1 3/5. That would just give me negative 3/5. So there is my answer, the exact value. So an awful lot of work going in there, okay? So good luck if you get that one right. And that brings us to the end of all the paper 1 questions that I've put in. I hope that's been okay. Thanks very much.